Let's solve Unit 10 Artificial Intelligence questions. Which of the following is not a valid property over two fuzzy relations R and S which must be obeyed for performing lambda cut defuzzification? Actually, this question paper contains questions on fuzzy sets, genetic algorithms. Earlier previous year question papers, maybe for 2 or 3 sessions, we had lot of questions on artificial neural networks. I think in one question paper there were lots of genetic algorithm questions. After that, for 2-3 sessions they gave vacation for it, and again genetic algorithm gets more focus here. Maybe the one who sets the question paper based on their own taste it is happening, I think. So let's get into the details now. Lambda cut defuzzification. What is it? In fuzzy logic, a fuzzy relation R maps pairs of elements from sets X and Y to a membership value that is lying in the range between 0 and 1. So in fuzzy sets, we have degree of membership. The values are between 0 and 1. In set it is either present or not. In fuzzy set it is how far it is a member. So the degree of membership is in decimal point between 0 and 1. Lambda cut of a fuzzy relation is a crisp set that includes all elements whose membership degree is at least lambda. Just for example I am telling you, just for understanding I am telling you. You have value like 0.3, 0.5, 0.7 and the lambda value is going to be 0.45. If it has at least lambda means only these two values will be taken under lambda cut, that is 0.45 cut, because it is having at least 0.45 as degree of membership. Now they are asking about which is not a valid property. Basically we have to know what is fuzzy set. Then we have to know what is defuzzification. In that we have to understand what is lambda cut defuzzification. How in fuzzy set suddenly fuzzy relation came. All these things will be running in your mind if you literally have no idea on fuzzy sets. Even if you have idea on fuzzy sets, you will forget about fuzzy sets when you find all this lambda cut and all. That too when you see these many symbols in the options, even if you are very much thorough with this particular concept, you will not be able to answer the question. This is a panic creating question, I would say. I cannot start from scratch and take you to the property, so we'll just see the options. The first option, union, is given here. The lambda cut of the union of two fuzzy relations equals to the union of their individual lambda cuts. These are the individual lambda cuts. This is the union of two fuzzy relation. Two relations are taken under union and it is given the lambda cut here. But here the relations have lambda cut individually and then they are combined in union. This union property is true, so we can mark option 1 to be true. I am just giving you the description of this particular symbol that is present in the option. Let's get into the intersection option now. The lambda cut of the intersection, this one, equals the intersection of the lambda cuts, this one. This is also true. Next we will get into the fourth property. This is called monotonicity of lambda cuts property. As lambda decreases, the lambda cut includes more elements, so higher lambda cuts are subsets of lower ones. See, now we are going to decrease this value to 0.3. This will include all the 3 values. What happens here? When I decrease the lambda value here, the lambda cut will include more elements. Earlier it had only 2 elements, now it is having 3 elements. So, higher lambda cuts, that is the one with 0.5 and 0.97 here, which is 0.45 value for lambda, are subsets of lower one, means the lower value had 3 elements, 0.3, 0.5 and 0.7. Is this the higher value one subset of this one? Yes, it is a subset. This is the monotonicity property of lambda cuts. For any lambda that is less than or equal to a beta value, where beta lies between 0 and 1, it is true that the relation with the beta value. Take this to be 0.3, the lambda value, and this to be 0.45. Now you can understand the statement from the example. The relation with beta value 0.45 has only two elements. That is a subset of the relation with the lambda cut value, which is 0.3, which has three elements now. So this is a subset of this one. This particular higher value is a subset of the lower ones, which is given here. So this property is also true. From this we can say option number 3 will be the right answer, because rest of the 3 options are right. Now we will see what is the problem with 3. Even at lambda is equal to 1, the lambda cuts of a fuzzy relation and its complements are not equal. They are disjoint. This particular property is true. They are not equal. They are disjoint. This is true. They have given exception as lambda is equal to 1. This is actually wrong and this is right. It means they say even when lambda is equal to 1, this particular property is holding true. But in the statement they have given except, which is wrong. How will you find complement of a particular fuzzy set? When you have a value called 0.3, the complement will be 1 minus 0.3, which will give you 0.7. Can this be equal at any point? No. Whatever is present here will not be present here. That is the case. If you take this to be double complement, say for example, instead of this symbol, if we have this to be double complement, this one is not equal to this one is true. Except for this condition is what we can say false. In case if this is going to be relation complement not equal to the complement of the relation, fuzzy relation is given in this way and this is a set relation. You can take it in this way. Set values will be either in or not. Say for example, if an element is present in complement, it will not be present. It is just 0 and 1. But here the case is degree of membership. So when we have 0.3, the complement will have 0.7. So this value will not be equal to this value is totally true, irrespective of any lambda value is what we can understand. So somehow we know 1, 2 and 4 are correct. So based on that we say 3 is wrong as per the notation that is given in this particular question paper. Next question. Which of the following is not a parent selection technique used in genetic algorithm implementations? So let's see the parent selection techniques first. We have already discussed about genetic algorithm phases, the selection technique related problems and all. So I am not getting into the usual genetic algorithm explanation. I am directly getting into the parent selection technique here. We have roulette wheel selection. Here the probability of selection is proportional to fitness. Next we have stochastic universal sampling. This is a more stable version of roulette wheel with multiple selection points. Have you seen about roulette wheel? You will be rotating a wheel and it will be going and pointing a particular person. So that one is roulette wheel. Next we have tournament selection. It randomly selects a group and picks the best among them. Tournament is available in option 2. So it's a parent selection technique. Next we have rank selection. Individuals are ranked by fitness. Selection probability depends on rank. So rank selection is definitely a technique. Next we have Boltzmann selection. This uses a simulated annealing principles to balance exploration and exploitation. So this is also definitely a technique. Next we have truncation selection. This selects top percentage of individuals based on fitness. And we have elitism technique, automatically carries forward the best individuals to the next generation. So what is not a technique here? Option 1 radial will be the right answer, but it is not a parent selection technique. I managed to collect the parent selection techniques alone. I did not get into some reference books. It was some web references only. Next question. Given that eta refers to learning rate, this symbol is mathematically called as eta. And xi refers to the ith input to the neuron. Which of the following most suitably describes the weight updation rule of a Kohonen self-organizing map called as SOM, where J refers to the jth neuron in the lattice. So there are two indices I and J. I refers to the ith input and J refers to the jth neuron in the lattice. If you have seen about SOMs in unit outline videos, you could have seen the lattice formation, how they are organized, but that is about general self-organizing maps. Now we'll just get into a learning and then mark the answer. A Kohonen self-organizing map is an unsupervised neural network model that transforms high-dimensional input data into a low-dimensional, usually two-dimensional grid of neurons. So transforming high-dimensional to 2D is what we call as self-organizing map. What are the terms used here? We have something called weight vectors. They represent the memory or prototype of each neuron. When an input vector is presented, the network identifies the best matching unit called BMU, the neuron whose weight vector is closest to the input. Then we update the weights of the best matching unit and its neighbors to make them more similar to the input. When you are converting from high dimensional to 2D, you should make them more or less similar. So for that purpose only we are updating the weight. The weight updation rule is given by new weight of the jth neuron will be equal to 1 minus eta into the old weight of the jth neuron plus eta into xi, the ith input of the neuron. So let's see the terms here. Eta will be the learning rate. It controls how much the weights adjust towards the input. When the eta value is small, we can say slow learning and more stability. When the eta value is large, it goes for a faster adaptation where we can have the risk of instability. So just check which option is actually equivalent to the given weight updation rule. We have 1 minus eta in two of the places, so the remaining two options can be taken down. And here we have eta into xi and here it is just xi. So we will also rule out option 3. Option number 1 will be the right answer. So when you see the diagram, you can understand how wij is coming. We would have worked in unit outline video. So if you don't understand Tamil, you can just look at the PDF that is available in my blog. That PDF is actually free for online viewing, so anybody can go and view it. Consider the following table defining the sample inputs and corresponding target values for a perceptron model. What shall be the value of the updated weights? After applying all the samples S1 to S4 in the order S1, S2, S3, S4 to this model. Given that the initial weights W1 is equal to 0, W2 is equal to 0. So there are two sets here, x1 and x2. x1 will be for W1, x2 will be for W2. Learning rate is equal to 0.1 and no bias is involved in the perceptron. The activation function for this perceptron is given below. Y observed is equal to 1 if Y in is greater than 0. Y observed is equal to 0 if Y in is less than 0. First we'll understand what is a perceptron. It's a type of artificial neuron designed for binary classification. It decides whether an input belongs to one of the two categories, just like spam versus not spam. So one will be given the value of 0 and the other will be given the value of 1. Weights are updated only when there is an error. When there is no error, the weight will be carried over. But when there is an error, we have to go for weight updation. How will we get the new weight? The new weight is given by the old weight plus learning rate into target minus output into the input value. What is this target minus output? It is the error. Error is equal to target minus output. So how can we write this? Is new weight is equal to old weight plus learning rate is given by 0.1 into the error into x, the input, x1 or x2 based on that. When you are calculating for W1, you have to use x1. When you are calculating for W2, you have to use X2. That is the thing. So error is equal to target minus output. Now we will understand what is target and what is output. Target is the correct label for the input. It will say whether it is 0 or 1. What is output? It is what the perceptron predicts after applying the activation function. What is actually this neural network model? We are actually giving training to the data. When we give training, we will give this is the actual output. But output is the predicted output. This is like actual and this is like predicted. So when the predicted output and actual output are going to be same, there is no error and you need not update the weight. But when there is a difference between the actual output, the target value and the predicted output, which is the output value, then you have to go for weight updation process. So this is the concept of this particular question. Now we will get into the working. Let's take the sample. How will we calculate y in? This is usually done by y is equal to W1 x1 plus W2 into x2. Output is based on y observed. So we will start working and you will understand how to do this. Let's start with S1 now. S1 means let's take this particular value. X1 is equal to 0, x2 is equal to 0 and we have target is equal to 0. So the actual value is 0 here. And we have weights as W1 is equal to 0 and W2 is equal to 0 for this particular sample. Now we have to find y in. W1 is 0, x1 is also 0 plus W2 is 0, x2 is also 0. What is 0 into 0? 0. 0 plus 0 into 0 is again 0, which will give you 0. This is the output value. Whatever you get here will be output value. Let me name it this way. What is the error here? Error is equal to target is 0. The output is this particular column's value, which is 0, which is equal to 0. Weights are updated only when there is error. Since the error is given as 0, we will take it as no error. So no change in the weights. So here also we will have W1 is equal to 0 and W2 is equal to 0. This value will be used for the next sample. Now let's take S2. What are the values of x1, x2 and target? x1 is equal to 0, x2 is equal to 1 and target is equal to 1. You have to remember that W1 is equal to 0 and W2 is also equal to 0. Y in is equal to, what is W1? It is 0. What is x1? 0 plus W2 is 0, x2 is 1. 0 into 0 is 0 plus 0 into 1 is again 0. What is the output value here? It is 0. Now we have to calculate error. What is target? It is given as 1. We are picking the value from this tabular column. So we have 1 minus the output is given as 0. We have error value as 1. When there is an error, the weight has to be updated. How will we update the weight? Let's take W1. W1 is equal to W1's old weight, which is 0 plus the learning rate is 0.1 into error is 1 into the x1 value is taken to be 0. So 0 plus anything into 0 is 0. 0 plus 0 will give you 0. Here we have W1 is equal to 0. What about W2? W2's old value will be 0 plus the learning rate is 0.1 into error is 1. What about x2 value? We have 1. So this will be into 1. 1 into 1 is 1. 1 into 0.1 is 0.1. So here it is 0 plus 0.1, which will give you 0.1. Now we have W2 is equal to 0.1. These are the updated weights. Now we will go for the next sample S3. Take this row now. X1 is equal to 1, x2 is equal to 0, target is equal to 1. Now we have different value for W2. So we have to apply this in S3 here. Y in is equal to W1 into X1, 0 into 1 plus W2 into S2, 0.1 into 0. 0 plus 0 which is equal to 0. Now error will be target is 1, output is 0 which is equal to 1. So there is error again. We have to update the weights. W1 new value will be W1's old value which is 0 plus learning rate is 0.1 into error is 1 into what is X1 value? It is 1. 1 into 1 is 1, 1 into 0.1 is 0.1. So 0 plus 0.1 will be 0.1. Now W1's weight is also 0.1. What about W2? The earlier weight will be 0.1 from here. Learning rate is 0.1 into what is error? It is 1. What about X2 value? It is 0. So anything into 0 will give you 0. This will be 0.1 plus 0 which is equal to 0.1. So here W2 value is also taken as 0.1. So let's update the value. In S2, W1 is 0, W2 is 0.1. Now after computing S3, W1 is 0.1 and W2 is 0.1 again. Both the values are 0.1 now. With this value, now we are working for S4. If you are not clear with what I am writing, you can take a piece of paper and work it on your own. All the values are given in the screen. The formulas are given here very clearly. Let's take S4 row now. All the values are 1 here. X1 is equal to 1. X2 is equal to 1. Target is also equal to 1. How will we calculate Y in now? W1 into X1. So it is 0.1 into X1 plus W2 into X2, 0.1 into 1. So this is 0.1 plus 0.1 which will give a value of 0.2. Here you have to look this particular activation function. Earlier we had 0 for Y in value. Since we had 0, we just marked it as 0. Now 0.2 is actually greater than 0. Since 0.2 is greater than 0, now the output will have a value of 1. That is, Y observed will have a value of 1. Since Y in is greater than 0, the output value will be 1. Now take the error. The target is given as 1. Output is also given as 1 and now error is 1 minus 1 which is equal to 0. What is 0 error? There is no error. If there is no error, there is no change in the weight. It means W1 value is retained as 0.1, W2 value is retained as 0.1. So we are having the same set of values. What is the question? What shall be the value of updated weights after applying all the samples in the order S1, S2, S3, S4 to this model? So what is the final set of weights we have got in W1 and W2? W1 is equal to 0.1, W2 is equal to 0.1. It is available in option number 1. Option number 1 will be the right answer. Always remember, when you get 0, you can stay in 0 itself. But when you have a value greater than 0, 0.2 is greater than 0. So you have to take Y observed value as 1. So instead of Y observed, I am just treating this as output value. So based on Y in value only, we are deciding the output value. So if you have not understood about this output value in the first 3 rows, at least in this row you would have understood. Next question. Consider the following steps used by a knowledge-based designer to represent a world. A knowledge-based designer builds structured representations of information about a specific domain. Already we had a similar question in the previous year question paper. The first step is to choose a task domain. Decide what world or area the knowledge base will represent. So we are starting with C. We can rule out 3 and 4. After selecting the task domain, we have to select atoms to represent propositions. Identify the basic building blocks, facts, variables, predicates relevant to the domain. After C, we are going with A. So let me mark here. The next step is to axiomatize the domain. We have to define rules, truth values and logical relationships that govern the domain. This is D. It is available in option 1 and not in 2. So we will rule out even option 2. The final step here is ask questions about intended interpretation. Refine and validate the representation by checking how the system interprets propositions. In fact, if you take the previous year question paper where I would have compared this to propositional logic, take a domain of integers, then select some variables for proposition, then define rules or logical relationship for the proposition, then ask questions about the proposition is whether they are true or not. This is how I would have compared it to knowledge base and then given you examples on propositional logic. So even if you don't have idea about knowledge base, just use propositional logic knowledge and then answer this question. So we will go with option number 1, CADB as the right answer. Next question, consider the following steps involved in the application of genetic algorithm for a problem. So it's about application of genetic algorithm. The first step will be calculating fitness of each member of the population. Here we will be evaluating how good each candidate solution is using a fitness function. So C will be coming first. We can rule out 1 and 4. The next step will be selecting a pair of parents from the population. Choose individuals based on fitness to reproduce. Example, the parent selection techniques like tournament selection and roulette wheel selection can be used. So we have already seen about the parent selection techniques in the same question paper here. So the next step will be A. C followed by A is in both the option. Then we have apply crossover with probability PC to form offsprings. Combine genetic material from parents to create new individuals. This is the next step. So here we are calculating fitness. Then we are getting into selection. Now we are in crossover. What is the remaining step as per the cycle? It is mutation. The final step will be apply mutation at each locus with probability PM. Introduce small random changes to maintain diversity and avoid local optima. This will be B. CADB is available in option 2. The same order as the previous question but given in different option. We will rule out even 3. Option number 2, CADB will be the right answer. So what is the sequence of steps here? This is the phase of genetic algorithm. So in genetic algorithm, we will be having fitness calculation, selection of individuals as parents. Then we will get into crossover operation to produce offsprings. Then we will go for mutation operation. So if you have the genetic algorithm in your mind, you will be able to answer this question even though they have given application of genetic algorithm for a problem. Next question. Consider the following statements regarding agent systems. Let's start with A. Agent system comprises of an agent and an environment on which it acts. The basic definition actually has this particular statement. So definitely A is true. The only option that has A true is option number 1. If you are sure about this statement without looking the other options, you can go with option number 1. A, B only will be the right answer. Now we will see what is right about B. The controller part of an agent receives, percepts from its body and sends commands to the environment. Percepts means the inputs received by an agent from its environment at a given moment. So receives percepts can be taken as receives inputs. How does it receive input? Using the sensors. It gathers percepts from the environment using the sensors. The controller will be processing the percepts and decide actions. The actuators actually execute the actions in the environment. So this is getting the input, this is deciding what to do, and this will be doing what it has to do. So B is also right. What about C? Agents act in the world through actuators which are non-noisy and always reliable. This is not true. In real world systems, actuators can be noisy. Their actions may not always produce perfectly predictable results due to uncertainty, mechanical limitations, or environmental interference. It is not always reliable. So both these aspects are false. So C is definitely wrong. Let's get into D. The actuators of an agent, the one that executes actions, convert stimuli into percepts. This is wrong. Only with the percepts you are actually deciding the action. Then how will the actuators convert stimuli to percepts? Sensors convert stimuli to percepts. This is the work of sensors. D is definitely wrong. Actuators perform actions based on decisions made by the agents. So if you know these 3 points, you can say D is false and B is true. Converting the stimuli into percepts. So these percepts become the input, and based on the input, the controller will decide the action, and that action will be executed by the actuators. Actuators are action performers. Next question. Consider the following statements regarding strips representation of a planning problem. This strips representation has a lot of details in unit outline videos. So if you want, you can refer the unit outline PDF that is available in my blog. Let's start with A. Strips is a feature-centric representation. It is wrong. Strips is an action-centric representation focusing on how actions transform the state of the world. So this particular part is wrong. A is definitely wrong. So 2 options can be ruled out here. The second one, the features describing state of the world are divided into primitive and derived. This is true. Strips distinguishes between primitive features which are directly affected by actions and derived features which are inferred from primitive ones using logical rules. So definitely B is right. What about C? The strips representation of the action comprises of precondition and effect. This is also true. Each action in strips is defined by preconditions and effects. What are preconditions? What must be true for the action to occur? The condition before the action is occurring. Effect means what changes in the world after the action. What has been added and what has been deleted. That part is given by effect. So if you have action here, we have precondition here and effect here. You can take it in this way. Statement C is also right. Now we have to check whether B is right or not. Strips can directly define conditional effects. No. Strips does not support conditional effects directly. It assumes that effects are unconditional. If the action is executed, all its effects will occur. Action is defined by precondition and effects. What changes are possible after the action is given? So they say it is about conditional effects, but here they say the effects are unconditional. Taking this particular term as wrong, we can say D statement is wrong. From this we can say A and D are wrong, so B and C are correct. Option 4 is also ruled out. Option number 2, B, C only will be the right answer. Next question, match list 1 with list 2. Operations on fuzzy sets are given in list 1 and the descriptions are given in list 2. We have intersection, bounded sum, bounded difference and algebraic sum. When you take fuzzy set operations for union, you will be calculating the maximum of membership, and for intersection you will be calculating the minimum of membership. Which of the options in list 2 is talking about minimum of degree of membership? It is option 4. A will be mapping to 4. Even if you have no idea about bounded sum, bounded difference, algebraic sum, you can answer this question only with A4 because A4 is available only in one option. The intersection of two fuzzy sets A and B is a fuzzy set where the membership of each element is the minimum of its memberships in A and B. Now we will learn about the other terms. The algebraic sum of two fuzzy sets combines their memberships while adjusting for overlap. It will combine both the membership while adjusting for overlap is this particular difference of the product. So algebraic sum D will be mapping to 1. D1 is available here. What about bounded sum and bounded difference? The bounded sum adds the memberships of two fuzzy sets but caps the result at 1. The value of fuzzy logic should not go below 0 and greater than 1. So when you go for sum, that is plus operation, the value may exceed 1, but they say the value can be minimum of 1 or the sum. So if the value exceeds 1, this minimum of 1 comma the value will cap the result at 1 is what they say. Say for example, if the membership has 0.5 and 0.6, it will result in 1.1. So 1 and 1.1's minimum value will be equal to 1. B will be mapping to 3. What about bounded difference? The bounded difference subtracts the membership of one fuzzy set from another but does not allow negative values. Sometimes 0.1 minus 0.2 can be the case. So they are using maximum of 0 and a negative value. So if this is going to be the case, 0 comma minus 0.1, when you take the maximum value, automatically you will stick to 0. When maximum function is taken for 0 and a negative value, 0 will be the result. When you take minimum for 1 and a value greater than 1, it will result in 1. So this is for difference and this is for sum. C will be mapping to 2. C2 is available here. Option number 3. A4, B3, C2, D1 will be the right answer. Next question. Match list 1 with list 2. Genetic algorithm termination criteria is given in list 1 and the descriptions are given in list 2. You can remind yourself about the genetic algorithm cycle and then find the termination criteria that will check whether to continue the algorithm or stop with it. So here these are the terms that involve termination criteria. These criteria help decide when to stop the algorithm based on the fitness of individuals in the population. So we will start with best individual, that is given in option B. Best individual ensures that at least one solution is excellent, which can be enough for convergence in some problems. Faster search convergence guaranteeing at least one best solution. The key term is here. B will be mapping to 4. So B4 is available only in option 1. From here itself we can conclude option number 1 will be the right answer. Now we will get into worst individual. If even the worst meets the standard, the whole population is acceptable. This can be equated to guarantees that the entire population to be of a minimum standard. So even if you take the worst individual, they would have met the particular standard. So worst individual A will be mapping to statement 3 in list 2. A3 is available only in first option. Next we will see about median fitness. It reflects the central tendency. If the median meets a threshold, at least half the population is performing well. At least half of the individual will be better than or equal to the convergence value. D will be mapping to 1. D1 is here. Now we will get into sum of fitness. Sum of fitness gives an overall measure of population quality, ensuring most individuals are within a desired range. Guarantees that virtually all individuals in the population will be within a particular fitness range. So this desired range and fitness range will be the key term for sum of fitness. C will be mapping to 2. C2 is again available only in one option here. Option 1, A3, B4, C2 and D1 will be the right answer for this question. With this we are completing Unit 10 questions.